Hi, right now I want to talk about chapter 4, Savitch book, edition 10. We're going to be talking about the second part, predefined functions. So we are going to be talking about the functions that's available to us and we can use it. So one of the reasons that we want to write functions is for other people to use it, or for ourselves to use it. So if there is any code that is going to be used in the future, we're going to put it in the function, but basically give it to other people to use it. So when we're talking about predefined functions, these are the functions that's available to us. They come in through the library. So when you download your compiler, it comes with a big list of libraries. So we're going to be bringing the things that we want because there are a huge number of things out there. We practically cannot bring everything to our program. It's going to be huge. So we're just going to bring the modules that we need, and we're going to be using them without writing the code. So your book has some example here that we're going to go through it. But first, before I go there, well, let me talk about those two first, and then we can go on it. So if I am doing a function, so for example, I want to do a square root. So instead of me writing the code for a square root, I'm going to use the one that's available. So the word square root is going to be the function. I'm going to pass a parameter to it, and then this one is going to return the square root of whatever I have here. So that's what this one is doing. So just to explain to you a little bit how the functions work in general, is the functions generally, they have a code, their code. So if you remember, we talked about this before in chapter 1 and 2, maybe. So when we run a program, our program goes to the memory piece of program, because the whole program doesn't fit. It's going to use a portion of the memory, and it's going to have, in reality, it's 3 parts, but let's talk about the 2 parts: the code or instruction set and the data. So when we are declaring data, it's going to go to the data section, and when we are writing the code, it's going to be translated to zeros and ones in instruction code, and it's going to go in the code instruction. So the codes are going to be there, and then our computer is going to execute one instruction at a time. So this section is for the code, and it has instructions in there. You will learn more about it in your assembly class. There was some instruction in chapter 1. So it's going to execute, because this is a top-down programming that we're doing. It's going to go and it's going to execute the first instruction. Then it's going to execute the next one. Then it's going to execute the next one, and so on. When it hits to a function code is just a code, and it's in another section of the coding part. So from here, when I'm here, and when I execute this instruction, it's going to jump over to another location that we have the code for the function. Then it's going to start executing those that belong to the function. So it's going to execute that one, it's going to execute that one. So it's going to execute all the code for the function. Then it's going to come back to the same place that it left. And then it's going to pick it up from there, and it's going to move on. And it's going to execute more instruction. So that's what's happening in the memory. I just want to mention it. I'm not going to ask you for a test or anything like that, just to have something in your mind. How does this work? Okay, so moving on, let me clear this out. Okay, so I have here function call. So whenever we call in the function, we're going to have a function call. So we have 2 types of functions. One are the one that return a value. ones are the ones that do not return a value. So for example, a square root does return the value. So we can take the, call the square root function, then this square root function is going to be replaced by its value. So let's say that sales is, I don't know, 25. So the square root of, so it's going to go call the function called the square root, and then it's going to come back and it's going to replace the whole thing with the result. We can assign it to a variable, or we can just use it in an expression, because this function returns a value. So we're going to focus on functions with return value on chapter 4. And then when we go to chapter 5, we're going to be focusing on some other functions, including functions which do not return a value. So if we want to look at the code, so that's, so this is a code for it. So I just want to mention a couple of things, few things in this code, just to remind you what I was asking you to do before. So every number that we have in our program is going to be defined as a constant. We're going to have a meaningful names for our variable names. Then we have our sections for input, and you can see that's clearly defined, and you can see it. So we put some extra lines in there. So that's input, processing, and output. So we're going to talk about those sections in here. So the input part, of course, what we talked about in our class, that every time you have an input, you need to validate your input. Then we go to the processing part. And one of the things that we have to keep in mind is we're going to put some spaces between our operators. So it's going to be easier to follow. So you can see this equal sign has some spaces around it, and that way it's easier to read. And then we're going to be talking about our output. So the section for formatting the output has to be in that area. All right, and this is the way we use the square root. Because our square root is going to return a value, we can put that value into another variable, or we can use it. So when it gets to this point, it's going to jump to another section. It's going to start executing those code for a square root, which I didn't write it. I just brought it in, and we're going to talk about the libraries and all those things. Just a quick note, the square root is from C math library, and we're going to talk more about it. And then it's going to put the value in here. So it's going to come back here. This is called calling function call. So when you call a function, it's going to jump somewhere, then it's going to come back. All right, so when we're talking about the function call, we will have a name of the function. This is for the function call. We're going to have a section to talk about how we're going to create function ourselves. But right now, there are functions that are created. Somebody else wrote it. We're just going to use it. So it's just like a function call. So I'm in the office. I have an intern. I'm going to call the intern. I'm going to say, do this task. Let's make it very simple. I'm going to tell him or her, I need 25 copies of each page for this. Of course, this is not a job of an intern, but let's say for the sake of discussion, I'm going to say that. So this intern or this person is going to go do that task and come back when it's done. Or I'm going to say, I need to do a research on this project. So this intern is going to go do a research, come back. So that's the idea of calling function. So how do we do it? We have the name of the function name, and then we have argument list. So when we're talking about argument list, if I have more than one, we're going to separate them by comma. So in this case, I have a square root that has one argument. So the argument is going to go in the parentheses. Part of the function is you have the parentheses, and POW has 2.5 to the power of 3. So that is the power. And both of these are returning values. So we can put them, assign it to a variable. We can use them just to print it out. So the result is going to be printed out. So when we're calling a function, the function is going to go execute the code, and then it comes back and replace itself by the result or the return value. Okay, so these functions are written by somebody somewhere, and they are organized with libraries. So the way that I can bring them into my code is to bring the libraries. When I start coding, we didn't have internet the way it is right now. So we had to kind of memorize what libraries do we need, and those kind of things. Now the IDEs want to let you know. You can just Google it if you don't know what the library you need. And you have a powerful IDEs, which they will tell you what you need. So these are, we're going to be using the pound include to bring them to our code physically. It's just like go grab this code and put it right here in our program. So you might start your code with 20 lines, and then when you try to compile it, your 20 lines becomes 200 lines because you're bringing some stuff from outside. So we're going to be using, and you have seen this before, we use it for IO stream. So we have the pound include CMAT for the mat, that square root is part of the mat. When we are going to be using namespace std, that's the way we are writing the programs for the Savitch book. So these are some of other functions that we see in mat, CMAT, and so one of them is absolute value. So the absolute value is going to take an integer and it's going to return its absolute value. So you might want to say, why do I want to need that? But we're just going over what we have for our functions. So this ABS is for the integers, and we have the same thing for FABS, and that's for float. Float is half of double. For some reason, Savitch want to use double, but float is a decimal point that is half the size of double. So that's why we use FABS. That's for the numbers with the decimal. So we can use that one, and it's going to return a double. So we can see some of these things in your book, and it's telling you about the libraries. So if you want to use ABS, LABS, that's for long. FABS, those are all part of the, FABS is part of the CMAT, but ABS and LABS is part of CSTD-lib, which is C standard library. Then we have a square root and a power, that's part of the CMAT. And then we have ceiling and floor. The ceiling is going to move your decimal point up, and the floor is going to move it down. So if I say floor, remember we were able to do that through integer, but integer, if I take a float or double and force it to be integer, I lose the decimal point. But if I use ceiling or floor, it's not going to lose a decimal, it's just going to adjust it. So I have ceiling of 3.2 becomes 4, ceiling of 3.9 becomes 4, and for floor, it's just going to go down. Now, for some reason in these things, it's not talking about the round function, but what we can do with the round function, we can we'll add 0.5 to our number and then use the floor for it. So if I have, let's say here, 3.2, so if I have 3.2 plus 0.5, that's going to give me 3.7. The floor of that is going to give me 3. And if I have 3.9 and I use 0.5, add 0.5 to it, that's going to give me 4.4. The floor of that is going to give me 4, which is the rounding point. So for the round, I'm going to add 0.5 to my round number, and I'm going to floor it. So it's going to be floor, and then I'm going to say the number that I have plus 0.5. So that's the way I'm going to be using it for my round. So this is going to be my round function. So that's going to round up for this one. Let me see if I missed anything. Okay. I want to talk about also random number generator. So when we're talking about a random number generator, it's going to be we are using a function that's available in library. We're going to bring it in and we're going to use it. So this will create a random number. So because we are using the computer to generate it, it is not really a random number. They're trying their best to write some code to create a random, but the computer is not a random thing, so it's going to try it the best it can. So that's why it's called pseudo-random. So first thing we need is going to be a seed that I need to create a random. I'm going to talk about why do I need a seed. So it's going to be part of the C standard library, cstdlib. So I'm going to bring the C time, and I'm going to talk about why we need that. So this is a seed is called srand, and we're going to put time 0 in it. And I'm going to talk about why we need that. So we're going to do srand one time in our program, one time, and then we're going to be using rand function to create random numbers. So it's talking about the rand function returns a random integer that is greater than 0 up to rand max. So it's going to be equal 0, less than rand max. Okay, so the function called rand with the parentheses, that's the way we're going to call it. Now, let's look at the program that's doing this for us. Where is my program? Okay, program. Okay, so when I see things like this, I'm going to ask a question, and this is something that I want to encourage you guys doing. So it says srand time 0. So the first question that I have is, what is time 0? Why is it 0? And what is the time 0? So what I'm going to do, one of the ways that I can figure it out is to print it out. Okay, what is time 0? Technically, the time in your machine started in late 70. They start putting a number, and every click that happens in your computer is going to add to that number. So we're going to, and time 0 means now, the time right now. So I want to know what is that. Then I go, it says that the random number is going to be 0, 1 less than rand max. So the question that I have is, what is rand max? So the best way to know it is what? To print it out. I want to encourage you guys to do these kind of things. When something is not clear for you, let's print it out. So I'm going to create random numbers and then I'm going to check it. So I am clearing this. I am going to run this program. Okay, so the time that's going to give me is this big, huge number. I want you to remember the last 3, 4 digit of this one, which is 2069. So I'm going to write it down, but you guys are better than me, so you remember it. So it's 2069 for the time. And then rand max is 32,767. That's the rand max that I'm printing. Then it's creating some random numbers for me. The first one is 147.17. The next one is 151.44 and 80.17 and so on and so forth. So I'm printing 5 random numbers. Now I'm going to run this again. Okay, and I want you to pay attention to what we had here. The last 4 digit was 2069, is 2125. So it is changing. So my starting point for creating a random number has changed. And the reason that we want to do that is every time we start, we don't want to start from the same point. We want to start with different point. Why do we want to do that? Because the algorithm that's used for the random is going to create different numbers every time. So the last time this one was 14,717, now it's 14,900 and so on and so forth. And if I run it again, these things are going to change. So this one is changed, this one is changed, and so on and so forth. Now, what's going to happen if I forget to put srand in there? So if I forget to put srand, let's see what happens. So the time 0 and rand max is still there. So my first number is 41. The next one is 18,467. I'm going to run it again. And you see, I'm getting the same numbers. So it is random, but because I'm starting with the same area, then I'm going to get the same number. So if you forget about srand, you will get the same range of numbers again. So if you're throwing a dice, you're going to always get the same numbers. So it's not really random. So we need that srand, but we need it only one time, because if you put it more than one time, it's going to lose the value that it has. So one srand, multiple rand, that's what we're going to do. Now, the next thing is, I might need numbers that are not these huge numbers that I'm getting. I need some numbers. For example, I might want to simulate the dice. So if I throw a dice, I want a number between 1 and 6. I don't want 14,567. So we're going to be using the percent. Remember, percent is for the remainder to get that going. So if I want to get the 6-sided die, I am going to do rand %6. So remember, %6 is going to give me 0, 1, 2, 3, 4, 5. Those are the numbers that I can get with %6. So if I take any number and I divide it by 6 and I collect the remainder, those are the remainders I can have. It cannot go anything else. If I take any number and I divide it by 6, the only remainders that I can have is 0, 1, 2, 3, 4, 5. But my die needs to have 1, 2, 3, 4, 5, 6. So what do? We add 1 to it. So it's going to give me, so if it's 0, it becomes 1. If it's 1, becomes 2. And if it's 5, becomes 6. So I'm going to get a range of 1 to 6. So that's the way we're going to create a random number for our purpose. So now let's do a practice together. We're going to be, so This is my range. I need 6 numbers and I need to start with 1. So that's the way it's going to be. So this is how many numbers do I need? What's my range? For a die, it's going to be 6 numbers. So I need 6 here. And then I'm going to add my starting point. So what about if I want to do 2 dice? How is that going to happen? What about if I want to do x greater than 10 and less than 21? How is that going to happen? So let's think about it for a minute, and then we can work on it together. So first thing first is, if I have 2 dice, what are the numbers that I'm going to be looking at? Let me put this one in there to remind you the way that we're going to create the random numbers. We're going to put the function rand, we're going to use the %, we're going to put the range in here, and we're going to put the starting point here. So first thing first is, if I'm creating 2 dice, how many numbers do I want? How many more numbers is going to create? So if I look at that, the 2 dice is going to give me 2 to 12. So these are the numbers that's going to give me. Now, what's the range? So the way that we're going to calculate the range, if we are including these numbers, that's inclusive, then we're just going to deduct 1 from the other one, and we're going to add 1 to it. So if the range is from 12 to 2, from 2 to 12 inclusive, meaning that 2 and 12 are part of it, then we just subtract 2 from 12 and we add 1 to it. So my range is going to be 11 numbers. So that means in a set of 6, I'm going to put 11 in there. Now, what is my starting point? My starting point in this is going to be 2. So I have my range and I'm going to have my starting point. So I just plug them in, and this is what I'm going to get. 2 dice, rand 11 and plus 2. So it's going to create these numbers for me. So if I run this 10,000 times, it's not going to be evenly distributed. And even if you play with 2 dice, certain number is going to happen more than the other ones. So the chances of getting 6 is much higher than the chances of getting 2, because you can have a combination number to get a 6. You can get a 2 and a 4, 3 and 3. So you're going to have high chances. That is not simulated in C++, so we don't have that. But even with that, if we run this 10,000 times, which we might do, then we can calculate which one was happening more than the other ones. So this is for this one. So let's move on to the next one. So the next one was, we want to create a random number for x that's going to be greater than 10 and less than 21. This is called exclusive, meaning that 10 and 21 are not part of my numbers. I don't want to have 10, I don't want to have 21, because it doesn't have equal sign. If it had equal sign, then it would be inclusive in that one. So 11 to 20 is going to create me these numbers. Now, what is the range? So I'm going to exclude 10 and 21, then I'm going to have 11 to 20. So I can use the same thing that I was doing up there, 20 minus 11, that's going to give me 9, plus 1 is going to be 10. So remember what I'm doing over here. I am not including 10, I'm not including 21. If I include them, then my range is going to change. So that's going to be, I need 10 numbers for this. So the range between this is going to be 10 numbers. I need the starting point. So where is my starting point? Where is my starting point for this? My starting point is going to be 11, because we're creating 11 to 20. So I'm going to plug these things into this one right here, and that's the way I create my random number generator for x greater than 10 and less than 21. Okay, so I'm going to stop right here.